This video is on prime numbers and composite numbers. Let's first talk about factors. In the product of 3 times 4 equals 12, the numbers 3 and 4 are called factors, and the result, 12, is called the product. So numbers that multiply to obtain a certain value are called the factors. We say that 3 and 4 are factors of 12. However, 12 also has other factors, because there's 2 times 6, which is 12, and 1 times 12, which is 12. So all of the factors are 1, 2, 3, 4, 6, and 12. So don't forget about the 1 and 12. You could always use 1 in the number itself. Those are also factors of the number. So this number 12 has, let's see how many, 3, 4, 5, 6 factors. 6 different factors. Okay. Another way of stating what a factor is, numbers that divide evenly into a given number. So all these numbers, 1 and 2, 3, 4, 6, and 12, they all divide evenly into 12. 2 goes into 12, 3 goes into 12, 4 goes into 12, all evenly without a remainder. The number 5 is not a factor because it does not divide evenly into 12. If you divide 5 into 12, you're going to get a remainder of 2. Okay, prime numbers. A prime number is a whole number greater than 1 that is only divisible by itself and 1. So the only number that goes into it is itself and 1. That number 12 would not be a prime number because other numbers went into it. A prime number therefore has only 2 factors, itself and 1. So that last number had, what did we say, 6 different factors? This one a prime number only has 2 factors, itself and 1. So let's start with a list of prime numbers. 2 is the first one. 3, 5, 7, 11, 13. See, look at the number, let's say 11. What multiplies to equal 11? The only product is 1 times 11. That's the only product. So it only has 2 factors, 1 and 11. The number 13, the only product that multiplies to give us 13 is 1 and 13. Therefore, it is a prime number. The number 10 is not on that list because what multiplies to equal 10? 2 times 5. So it is not a prime number. So each of these numbers is only divisible by itself and 1. And by the definition, a prime number must be greater than 1. So that makes the first prime number 2. 2 is actually the only even prime number. Now prime numbers, they go on forever. There's no last prime number. There's an infinite amount of prime numbers. But 2 is the only even prime number. Okay, composite numbers. Well, if it's not prime, it's got to be something else, right? That's called a composite number. A composite number is a number that is divisible by other numbers besides itself and 1. A composite number has more than 2 distinct factors. So the other numbers would be 4, 6, 8, 9, 10, etc. It has odds and evens. 15 is an odd composite number because 3 times 5 is 15. So not all evens. There's a combination of even numbers and odd numbers. but they have more than two distinct factors. So the first composite number is 4. Now, here's a trick. We're going to try to determine if a number is a prime number. So if you could find a number that goes into the number evenly, then it's not a prime number. It is important to be able to determine whether a number is prime or composite because it will be a necessary part of the prime factorization process. That should say or right there, prime or composite. In the next video, we're going to perform prime factorization. And the prime factorization process is necessary for concepts such as reducing, and adding, and subtracting fractions. So that's what we're getting ready for. We're getting ready for fractions. And if we don't have this down, we're not going to be able to perform prime factorization. And if we can't do prime factorization, we can't work with fractions. So it's kind of like a snowball effect. We have to keep learning one thing before the other. Everything just keeps building and building and building. Think about division. I like to tell my students this all the time. If you do not know how to multiply and subtract, can you learn how to divide? There's no way. You cannot learn division until you've mastered multiplication and division. Pardon me, multiplication and subtraction. Well, this concept applies in math in general. You have to learn, you can't do section 2.5 without doing 2.4 and 2.3. You can't take algebra until you've mastered your arithmetic. Okay, enough of that, right? Let's keep going. So, a procedure. To determine if a number is prime or composite. To determine if a number, got too many if a numbers are here, right? Okay, so determine if a number, sorry about that little editing, is prime or composite. Use the test of divisibility to determine if it is divisible by 2, 3, or 5. Remember, 2 is, the test is even digits. 3, we have to add the numbers and then divide by 3. And 5 is if it's a 0 or a 5. These are the first 3 prime numbers. So that's what we're doing. We're trying our prime numbers. Now, if the number is not divisible by 2, 3, or 5, we will continue with the prime numbers beginning at 7. Now, there wasn't a test for 7, so we just have to check to see if 7 divides evenly into the number. If 7 doesn't work, then what's the next prime number after 7? And that is 11. So you want to know these prime numbers, especially the first few. Definitely. After 11 would be 13. After 13, that's right, 17 is not 15. 15 is composite. Okay, so we want to check these numbers, but we're not going to go on forever, right? We only continue this process, so I'm reading step 3. Only continue this process until the prime number you are dividing with is a number that when multiplied by itself, the result is larger than the number being tested. Okay, we'll talk more about that. Or another way of knowing when to stop is when the number in the quotient is smaller than the divisor. Okay, it's a little tricky to figure out when to stop, but we'll figure it out. Okay. Determine whether the following are prime or composite. 87. So we're just going to start looking at our divisibility test. 2. Does 2 go into 87? No, it's not even. Does 3 go into 87? Yeah, because if you add 8 plus 7, 8 plus 7 is 15. Does 3 go into 15? Yes, it does. So it is composite because it is divisible by 3. Okay, so we go through the numbers 2, 3, and 5. After that, it's 7. Okay, so 97. 2, does 2 go into 97? No. 3, does 3 go into 97? Let's see, add the 9 and 7. 9 plus 7 is 16. Does 3 go into 16 evenly? No. The next number is 5. So remember, we're trying 2, 3, and then 5. Does 5 go into 97? No, because it doesn't end in a 0 or 5. So 2, 3, or 5. So the next number to try is 7. So divide by 7 to see if it goes in evenly. And it doesn't go in evenly. The next number to try is 11. Now, what's 11 times 11? It's 121, which is larger than 97. So we could stop there because 11 will not go into it. If you try to divide this by 11, the other part of that step 3 said that if the quotient is smaller than the divisor, so if we divide 11 into 97, well, 11 times 9 is 99, so that's too big. But notice that the 9 on top would be smaller than the divisor. So that's it. We could stop there. We could therefore say that this number is prime. It's only divisible by 1 in itself. Okay, so after 7, 11 is too big, it won't work, so we're all done. There's no need to try 13 or 17. It's over. Okay, let's do another example. 835, prime or composite? 835, so let's see. 2, does 2 go into 835? No. 3, 8 plus 3 plus 5, that is 16. Does 3 go into 16? No. Number 5, is the last digit a 0 or 5? Yes. So it is composite because it is divisible by 5. Okay, 119. Again, we start with 2, and then 3, and then 5. So 2, no, it's not even. 3, 1 plus 1 plus 9, that's 11, no. 5, not a 0 or 5 at the end, no. So those tests do not work. So next is 7. Let's divide this by 7 and see if 7 divides evenly into the number. It does. So therefore, it is a composite number because it is divisible by 7. Is 143 a prime or composite number? So this time it's just one number to try. Okay, let's start with the number 2. Does 2 go into it? No. 3? 1 plus 4 plus 3, that's 8. No, 3 is going to 8. 5? No, doesn't end in a 0 or 5. So those tests do not work. Next number to try is 7. Let's divide this number by 7 and see if it comes out evenly. I got a remainder of 3, so my answer to 7 is no. What's the next number to try? What's the next prime number after 7? 11. So we're going to divide this by 11. Now 11 times 11 is 121, so it's okay to try. So divide by 11 into 143, and it actually works out. It's kind of tricky, but it's a composite number. So 143 is composite because it is divisible by 11. Takes time, but we got there. Okay, let's see what's next. Multiples. A multiple of a natural number is a product of that number and any natural number. So multiples of 4, 4, 8. If you keep increasing by 4, they're called multiples. 4, 8, 12. Or you multiply that number by the natural numbers. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16, etc. So that's why we say it's a product of that number and any natural number. Okay, list the first 10 multiples of 7. So start with 7, and then just keep writing all the multiples of 7. 7 times 1, 7 times 2. So 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21. What are the next ones? Let's see, 7 times 4 is 28. 7 times 5 is 35. 7 times 6 is 42. That's 6 multiples. We've got 4 more to go. 7 times 7. 7 times 8. 7 times 9, 63. And then 7 times 10, 70. Those are the first 10 multiples of 7. Now, the reason I brought up multiples here is I just wanted to mention that there's a relationship between prime numbers, composite numbers, and multiples. And that is, every composite number is a multiple of a prime number. So like the prime number here that we're talking about is 7. 7 is a prime number. All the multiples after it are all composite, and they're multiples of the prime number. So for example, I put 45 as a multiple of 5. It could also be a multiple of another number. It's also a multiple of 3. So that's just a relationship between prime numbers, composite numbers, and multiples. Okay, that's it for this video, and I'll see you here for the next one. Have a good day.